we're on pages 68 and 69 of our textbook. We begin Unit 3, which is entitled Exponential Functions, and our first lesson is exponential properties. On the left-hand side, we have several properties in their general form that we're going to go over, and on the right-hand side, we have an example. So for some of these, we may just start with the example first and then fill in the general rule. Our first example, a to the fourth times a to the second, is a to the 4 plus 2, which is a to the 6. So our rule for multiplying x to the a times x to the b is going to equal x to the a plus b. So when multiplying, we want to add the exponents. And remember, exponent and power are the same vocabulary word. Our next example, 3 to the 5th divided by 3 to the 4th. If I was to write this out, 3 times 3 times 3 times 3 times 3 divided by 3 times 3 times 3 times 3, right? 5 3's here, 4 here, and pairs would divide out, leaving us with 1 3. So that would be 3 to the first, which is simply 3. Well, what do we do with 5 and 4, the exponents? We subtract them. The general rule, x to the a divided by x to the b, is going to be x to the a minus b. So when dividing, we subtract our exponents. Our next example, a to the 4th raised to the power of 2. Well, this would mean a to the 4th times a to the 4th, right? And then when we're multiplying, the rule is to add, so we get a to the 8th. And what can we do with 4 and 2 so that the result would be 8? We multiply them. So when you have a power raised to a power, you multiply the powers. X to the a raised to the b would be x to the a times b. Next, we have a product raised to a power, meaning we have this example 3 times a times b times c, all raised to the power of 3. Again, we could write that out, 3abc times 3abc times 3abc, and then we'll simply get 3 times 3 times 3 is 27. Multiplying the a's, that's a to the 3rd, b to the 3rd, c to the 3rd, which would be the same as if we simply distributed the power. So when we have a power of a product, we distribute the power. So the general rule, x, y, z raised to the power of a, you're going to distribute a to the x, to the y as a power, and to z as a power. The same applies if we have a quotient, okay? In our example here, we have 3a divided by 2 raised to the power of 3. So this distributes to both the numerator and denominator. So we would have 3 to the power of 3, a to the power of 3, over 2 to the power of 3. And I can leave that or clean it up a little bit. That'd be 27a to the 3rd over 8. So our quotient here, x divided by y raised to the a, is going to be x to the a, y to the a. Now this distributing the power only works when you have a product or a quotient raised to a power. It does not hold true if you had a sum or a difference, right? X plus y plus z raised to the power of a does not equal. You do not distribute over addition or subtraction. Only distribute over multiplication or division. Next we have zero exponent. So 9,999 raised to the 0 is, you could put it into the calculator if you wanted to, which I just did. It's 1. Anything raised to the power of 0 is 1. So x to the 0 is 1. Our next example, or let's look at our rule. A 0 exponent with a coefficient. We have a x to the 0. Well, this power belongs to only the x, right? A does not have a power of 0. The power of a would actually be 1, imaginary 1 there. So only x has the power 0. So x to 0 is 1, and then a times 1 is simply a. So when we have our example, 9,999, x to 0, again, this power of 0 is only with the x. So x to the 0 is 1 times 9,999 is just that, 9,999. What if we have a negative exponent? Let me look at the example. 3 to the negative 3. 3 raised to the negative 3. Well, it gives me this decimal. This is a repeating decimal. So then on the calculator, what I can do is press math. And the first option is fraction. So just press enter and enter again. That's equal to 1/27. So 3 to the negative 3 is equal to 1/27. Well, how do we get that without the calculator? If you have a negative exponent, to write the term with a positive exponent, you put it as 1 over 3 to the positive 3. And 3 to the positive 3 is 27. So this is equal to 1 over 27. So in the general rule, x to the negative a is going to equal 1 over x to the positive a. A fraction raised to a negative exponent. Okay, so what if we have a fraction raised to a negative exponent? Let's see. Let's look at the example first. So I'll do parentheses, alpha y equals fraction, 3 over 4. Close my parentheses, and it's raised to negative 2. Press enter, and we get 16 ninths. All right, so this is equal to 16 ninths. Oh, all right, so let's take care of the negative exponent by making it positive, but in order to do that, we would take our fraction here and invert the fraction. So this would be 4/3 raised to the positive 2. And then we distribute 4 to the second divided by 3 to the second equals 16 ninths. So when we have a fraction raised to a negative, in this case x divided by y raised to the negative a, that's going to be equivalent to y over x raised to the positive a. Next, a fraction with a negative exponent in the numerator. Okay, so here we have x to the negative a divided by b, and what we can do is take this and bring it down into the denominator, but with a positive exponent. So that's, our numerator would now be 1 over x to the positive a times b. In our example, this goes down, so circle it and put an arrow down. That would be 1 over x to the positive 3 times 7. I'll put the 7 in front. And our last example, well, what if we have a negative exponent in the denominator? Right, it's just going to move up into the numerator with a positive exponent. So this would equal b times times x to the positive a. In our example, that goes up, 7x to the positive 3. Now some practice putting this all together. So we want to simplify. Whenever you see the word simplify, it means to perform all operations. We have a fraction here, so let's work on the numerator first. We have multiplication, y to the 4th times y to the 3rd. We add those exponents, y to the 7th. Our denominator, y to the 2nd raised to the power of 3. We power to a power, we multiply, so that's going to be y to the 6th. And now divide. Y to the 7th divided by y to the 6th, we subtract our exponents. That's y to the 7 minus 6, which is 1, which is simply y. In 2, there's nothing to do in the numerator. The denominator here, we have a negative x raised to the power of 4. So that means we distribute the 4. So it's a negative x times negative x times negative x times negative x. If you have an even number of negatives, your result is positive when you're multiplying. So this is the same as x to the 4th. Our numerator stays. Now we have division. What's x to the 5th divided by x to the 4th? Well, it's x to the 1st. And take this negative and just bring it down in our answer. So negative x. Number 3, in the numerator, we have a product raised to a power, so let's distribute that power. So this becomes x to the 5th, y to the 5th. And the denominator, we just copy over. Now, division of like variables. In this case, x to the 5th divided by x to the 1st is going to be x to the 4th, right? We subtract our exponents. And y to the 5th divided by y to the 3rd is y to the 2nd. Number 4, we have this product here raised to the power of k. Well, product raised to a power, we distribute. So this is x squared raised to the k, y raised to the k. Now a power to a power, we multiply. So this is simply x to the 2k, y to the k. Number 5, we have product 1/2 x squared raised to the power of negative 3. So there's a few different ways we could do this. We could distribute, that's one way. We want to distribute the negative 3, or we can take care of the negative by inverting what we have in parentheses, right? So let me just write this. 1/2 times x squared is the same as x squared over 2, right? Now, if I invert the fraction, this becomes 2 over x squared to the positive 3. And now distribute. This is 2 to the 3rd, x squared raised to the 3rd. 2 to the 3rd is 8. X squared raised to the power of 3 is going to be, we multiply those exponents, x to the power of 6. So 8 over x to the 6th. Number 6, we have 2 to the x times 2 to the 4th. Same variable here. When we're multiplying, what do? We add the exponents. So this is 2 to the x plus 4. And our last group of 3, x to the negative 1 times y. Well, there's nothing to do in the numerator, nothing to do in the denominator, so I'm going to move around, right? This is going to go down to the denominator with a positive exponent, and the y to the negative 2, I'll move up to the numerator with a positive exponent. So let's see, we have that y remains, this y comes up, and this x remains, and the x to the negative 1 comes down as x to the positive 1. Okay, and we multiply across the numerator, that's y to the positive 3 over x squared. Number 8, nothing to do in the numerator or the denominator. We do have some moving around that we can do. To move this up to the numerator, everything else would stay. So I have 2x squared y times y, that y remained, this one moved up, over 6x. 2x squared y squared over 6x. Okay, now the 2 and the 6 reduce to 1/3. And x squared divided by x to the first is x, y squared. And their last example, we're simply multiplying. There's nothing to do inside this parenthesis nor this one. All right, so we have 4 times 4, which is 16. X to the second times x to the first, we add the exponents, x to the third. Y to the negative 4 times y to the negative 3, adding the exponents is y to the negative 7. Thank you once again for your attention.